So Barry, we've got quite a list of questions that came in uh, from folks, and they're in the comment section. I've been entering them there. But a university researcher asked, "Are you aware of what labs and institutions are doing research in magnetic launchers and coil guns?" So in other words, if you wanted to follow along where um, where you could get some inspiration, do you know of programs or labs that are doing work in this space that people ought to be paying attention to?
Oh, I have to admit I don't have good contacts and I have not paid much attention to what labs and research is going on there. Um, the search engines are your friend. I know there's activity going on. There have been some very powerful rail guns done, and I won't try to quote the name for fear of getting it wrong. Um, and the more engineering person, I would recommend if you have access to IEEE library. They do have transactions on magnetics and pulse devices that almost certainly have useful information.
Great. Um, Another question came in. The person is wanting to know, is the control problem or processing to do control, is it for a multi-stage launcher? Is that about is processing the issue, sensing and processing? Is it the power switching? Or talk a little bit about to finesse a multi-stage one. Where is the control issue that people are going to come in run into?
If I understand the question correctly, they want to know what kind of issues are involved with high-speed control of these circuits.
Mm-hmm.
Um, and, and first of all, at 10 or 20 meters per second, I don't consider my devices high speed at all. Where I expected problems to come in would be in the response time of optical sensors.
Mm-hmm.
Many of them include circuitry that would amplify and buffer the signal. That takes time. And it may take some special engineering to come up with really fast, we're talking a few microsecond detection to trigger the next stage.
Mm-hmm. But you don't see the whether you're using SCRs or MOSFETs or however you're doing the switching, the timing on that, so the higher current switching is not as much of an issue for you. You don't think?
Yeah, I don't see any obvious issues up front about high-speed switching with modern semiconductor devices out there.
Okay.
MOSFETs, small the gate drivers, IGBTs, they're all very fast in the down to the microsecond range. The first issue to look at there is the associated inductance and the circuit characteristics around those parts that would slow down switching, and that can quickly become deadly in there. Deadly in the sense that it's just too slow to keep up with what you want to get done. Keep leads short, maybe wires, and minimize inductance and resistance everywhere.
Okay. Um, Next, we had, and I think you probably addressed this. What are some good sources for info on circuit design and available components and everything? Um, so you pointed out some links. Do you think that those are pretty thorough for a person that wants to explore this? What about for a beginner? Would there be a good place for somebody that just doesn't have much circuit design experience at all? So, would you recommend anything else?
Oh, well, for beginners to get started, I highly recommend the Arduino area. There's a lot of technology and user groups out there, lots of stuff on the web. That's not so much basic circuit experience, and I'm afraid I don't have a lot to offer in that regard. Not being a beginner, I haven't explored that area much.
Okay.
I'm hopeful that online university courses may be helpful. I have no experience with them; it's pure guesswork. I've seen good work done in the Evil Genius series of books. I'd recommend exploring those and see what people can find. And I'd have to say most often the people I've helped and seen be most successful with this are students that are in a school of some sort, but really any sort. I've worked with high school students that have a mentor either in shop or the electronics classes there. Anywhere you can go to find a mentor that can see and touch and help you along on this firsthand, you'll be far better off than trying to learn everything from the internet. That is kind of slow, although ultimately the internet is the repository of all useful knowledge.
Good. Always send people back to the internet. um, had a good question from an electrical engineer. Can you talk a little bit about, you addressed, how many layers of coils you did. I think that was back on Mark 2 or 3, that you discovered that, having 14 layers wasn't really important. Coil design, you also actually in the Discovery Channel one, you talk about a pancake coil versus an open coil. Um, you know, are there opportunities to do any exploration in really, intricate coil windings, or is really circular coil winding kind of the optimal way to do it? Can you talk a little bit about that?
Yeah, I didn't go into the physics of coil guns much, but there's some interesting things going on. The alternatives to what I've done, the technology I've used to date is that of drawing some plain iron into the middle of a solenoid and letting it coast out the other side. Technically, they call that a switched reluctance motor, SRM, switched reluctance motor. Um, Other types can actually have much higher efficiency. The Discovery Channel coil gun, for example, that pancake coil, was a linear induction motor of a sort. The pancake coil would induce current on an aluminum plate that was resting on the pancake coil, repelling it away rather than drawing it in, as mine do, repelling it away. And on top of that aluminum plate was an object that they launched that looked very much like a rocket, but it wasn't. It was just an object that coasted out the other side. Linear induction motors are highly interesting and have great promise for being more efficient than the coil gun I've done, the switched reluctance motor. The reason I didn't choose induction motor technology is that this induced current in whatever is launched creates heating. So the upper limit of how fast you can launch an object using induction technology is how hot can that object get before it melts and fuses inside the bore. In theory, my switched reluctance motor, that is Mark 1 through 5, has no heat in the object, and in theory, you can keep adding coils forever. So that's two things to look at. Another technology to consider would be to take something like what I've done and conduct current through the projectile to magnetize it, that is, carry a magnetic field due to the current in the projectile. I won't go into it other than think about all the types of rotary electric motors we have now, and think about how can we unroll that in a linear fashion to become a linear motor. Everything that applies in the electric motor world could conceivably used in some manner if you can cut the round motor, lay it out flat, and start launching things magnetic.
So, getting so that we don't have all of our people that are non-electrical engineers glaze over here, we'll get to a couple more kind of basic questions. Somebody just said, what's the practical bore diameter limit for a person working on their own? In other words, could somebody, even though the energies aren't necessarily very high, but could somebody, have a bore and be launching projectiles that are, 1 to 2 inches in diameter, or is it really, do you have a sense of a size for the projectile?
Yeah, as for me, I recommend a bore diameter not much more than an inch. because when you go beyond an inch, 2.5 centimeters, then the energy storage requirements become really quite daunting in order to launch that.
Right. So,
Likewise, there's a lower practical limit, I would hasten to point out. If you're much below, say, a centimeter diameter or so, then the projectile will saturate magnetically and reduce the amount of energy that you can apply to that.
oh, interesting. I'm going to jump ahead to a question that's a little bit related to that. Somebody asked, is the iron content in the projectile important? So this person asked it. This was actually before the call started. They said, if they want to know, could you use a solid iron thing as a sled for something else, to launch things that are not iron based? Or does the ratio of iron to mass of the projectile play a big part?
Oh, yeah. Hey, there's lots of interesting aspects about the material. Um, First of all, the goal in coil guns is to get the permeability, the ratio of permeability to mass as high as possible. That is, the magnetic characteristic of how well an object absorbs magnetism or conducts it, if you will, is called permeability. And a higher permeability material will work better than lower. So that's one point, is choose the right material. The other one is, sure, the non-ferrous or the non-iron stuff, you can add as much mass as you want, but remember that ratio of permeability to mass is important in order to reach good speeds. So practically speaking, there probably is a limit as to how little or how much, on a percentage basis, of iron you use. Fortunately, the shape of the iron is not terribly important. It could be hollow, and you could embed some of the material inside it. It could be threaded, it could be anything else, any other shape, as long as it fits in the bore. As a digression, let me mention for a minute, one reason that we haven't talked about coil guns being impractical is that there's no rifling, they don't spin. When the projectile comes out the end of the bore, it begins to tumble a short distance away. I shoot these little iron cylinders across the room. They hit a target about three meters away, and I've been able to observe the object will tumble within 1 meter of leaving the barrel. So
Okay.
to become a practical device, someone would want to study the trajectory and how they can stabilize it. Maybe spin stabilize, maybe something else. But that's another big thing about being practical.
Well, that's probably an area that somebody could really explore and benefit the whole community. I think we have time for one last question, and I think this is a great wrap up. So this person said, are there any practical uses for this? Can an entrepreneur go into the coil gun business today? And if not today, is this something that, because of other things going on, that, knowing this, that, you might actually be able to use this as your livelihood at some point in the future?
Well, here's the attraction of coil guns. The principles of magnetic design are the same everywhere. We're applying it to this particular problem, but once you understand the principles and can work with it on a design basis, the sky's the limit. Well, not literally. You can't produce a magnetic air car or space vehicle as Dick Tracy proposed, but there's all kinds of applications for this linear motor type of design. The applications that make sense and are practical today are more along the lines of precision control, that is, moving parts around either up and down in a line or around a flat surface using magnetic control from underneath the part. I'm afraid I can't think of a good practical use for coil guns specifically with the technology that we have today. The promise is out there if we can make it work well. The promise is out there. Think, for example, of a nail gun, which today is most often done with compressed air to throw nails at high speed into wood, high enough speed that they'll they'll embed completely in the wood, just like you do with a hammer. Think of motion control. One person was asking me about the idea of we want to lift things from below ground to above ground. We want to dig a well and have coils or something on the outer shell of the well that would be able to lift packages up and down. All we have to do is run power down there instead of these long, strong cables that would lift from above. In my mind, that's interesting and exciting. I can't think of a practical way of doing it, but those sort of motion control problems, I think, are of great interest and could be dealt with practically with what you learn from Coil Guns.
Well, thank you very much for your time today, Barry. Thanks to everybody that submitted questions. It was great to have a great group of questions. As we mentioned earlier, Barry's website is actually already on openlydisruptive.org. If you go to our site and just look at the story on, there's a posting already there on magnetic launches, and there's a link to Barry's site. The presentation with his notes, his slides with all of his notes, including all of the links that he referred to, will be posted shortly, and video archive of this will be posted. We'll edit it down to make it YouTube friendly, and those will be posted shortly as well. But Barry, thank you very much for all your support with this. It's been a great presentation. Thanks everybody for joining us, and join us next month for the next hands-on ideas, when we'll meet some folks that are actually doing mobile